Hello everyone. Today we are going to discuss about the very important topic, which is hashing. Hashing is a technique which is to store and to retrieve the data. Hashing is a technique to store and to retrieve the data. Right. So we will be storing the data and we have to retrieve the data. So when we are putting the data, where we have to put the data, how we have to retrieve the data, where we have to put the data, how we have to retrieve the data. Now, before we going to talk about this in detail, let's see what are the terminologies we will be having part of hashing. So the terminologies are search key, hash table and hash function. So what is search key? So when you are putting some elements inside of your hash table, so this is your hash table where we'll put the elements or we'll store the elements. Where we'll store in hash table. In hash table we'll store the elements. Right. How we'll store? We'll store the elements into hash table by evaluating the hash function. We'll store the elements. The elements are called as keys. The elements are called as keys. Now, keys will be placed into hash table by evaluating the hash function. Now, what is this hash function? Hash function will be defined or will be evaluated in the following methods. The first method is division method. Division method. This is also called as modulo method. This is also called as modulo method. Hash function is we will be evaluating this hash function with the use of division method, which is also called as modulo method. And we do have other method. The other method is mid square method. So using of this method, we will be evaluating the hash function. Now let's see what is hash function. Hash function is h of k. Now we are writing this hash function to store the elements of k. Now h of k is equal to k percentile m. Now this is the modulo method. Now what is your k? K is nothing but search keys. K is nothing but search keys. K is equal to, we will be given with some input. We will be given with some input or some elements. We will be given with some input or some elements. Now elements are nothing but example 10, 15, 18, something like this. Now the first element is called as ki. The second is ki plus 1. The next is ki plus 2. Now I value will be 0 to m minus 1. Now what is this m? Maximum size. M is maximum size. Okay. Right. Now what is this ki? Now come here. K percentile m. Now here we will be substituting. If I wanted to, now h of 10. My first element is 10. Now h of 10 is equal to 10 percentile. Maximum size I am taking as 10. Now 10 percentile 10, the answer will be 0. Now using of hash function, we got 0 value. Now this 0 will be referring as the location. This is referring as location or it's a value where you have to place the 10. 0 is the location or it is a value which indicates us to place 10 into this place. Now let's see the how we will do this. Now I'm considering the hash table. Now hash table will consist of keys and values. Hash table will consist of keys and values. Right, now this is my hash function, right? This is my hash function. Now hash function inputs are what? Three inputs I have. K1 is 10, K1 is 10, K2 is 15, and K3 is 18 I have taken from the normal example to understand the concept. And here look at this 10, 15, 18. Now what we are doing, these are my keys and which are given to hash function to evaluate in this way. Now we'll get a value. So as far as 10 is concerned, we got which value? 0. We got 0 value. Now 0. Now let's give the numbering to this hash table. Now hash table numbering is maximum size is 10, right? 3, 4, 5, 6, 7, 8, 9. Now as I have started from 0, I should end this till 9. Right. Now this is my hash table. Look at this. This is my hash table. Now this is my hash function. What is my hash function? So I told you that I am approaching division method. So division method is k percentile m. That is k. K is what? Key. Now the first key is what? 10. 10 percentile 10. Answer is 0. Now 10 should be located in 0th location. So now this is your 0th location. Now you have to place here 10. That way we are storing, right? The hashing is what? Storing. How we are storing? So in this way we are storing, right? And the next value. And the next value is what? 15. Second value is 15. Now the same way we have to calculate. So again, h of 15. H of 15 is equal to 15 percentile 10. Now when you are performing modulo operation, answer will be the remainder. When you are performing this modulo operation, answer will be the remainder. So 15 percentile 10, remainder will be 5. Now 15 is a key. It has to be available in 5th location. Now come to hash table. Now 5th location, it should be 15. Okay. Now the third, h of 18. 18 percentile 10. Answer will be 8. Remainder will be 8. Now 15, 8. 18 should be available in 8th. So hash table will consist of all these are keys and these are values. These are keys and these are values. Value is referred here as location. So in this way we'll place the element. Now this is what your 0 and your 5 and this 8. 5 and 8. Now look at this. This is what? Hashing implementation. So hash function is called as a good hash function. Good hash function when it is doesn't have any collision. Good hash function when it doesn't have any collisions. What is collision? Collision is if a same location is accessed by two keys. If a same location is accessed by two keys, then it is called as a collision. Okay. Now, so as it is not having any collision, every location is given to one element, one key. So no two elements are in the same location, right? So no collision. So the hash function, now it is referred as good hash function. So good hash function means without any collisions. So this is what a simple technique of hashing, right? Now let's see how to retrieve the data, and what is the complexity of it. When we apply searching, actually in some other way, hashing is searching technique. Hashing is a searching technique. So what is searching? That we will be finding element, right? We will be, it's similar to searching. It's similar to searching that we will be finding a key element. When you have a list of elements, we used to find out the element. Now let's take searching techniques, linear search and binary search. In linear search, if I wanted to find any key element, so what I have to do, I have to, let's take the example that I wanted to search 15. Now my input are 10, 12, 13, 6, 8, 15. Now these are my input here. Now I wanted to search 15. What I'll do, I will be taking one array and we will be checking whether each element is 15 or not. Am I right? We will be taking input into an array and we are checking whether each element is equal to such element or not. So in this way we have to find out availability of a key element. So when we are doing this, the complexity will be what? Linear search. We have to check all the n elements. We have to check all the n elements. So 10 is 15 or not, 12 is 15 or not, 13 is 15 or not, 6 is 15 or not. When we found the correct element, 15 equal to 15, now search will be finished. So here in this, we are checking for big O of n. The comparisons are n elements we have to check. Now as far as binary search is concerned, we will be sorting the list before approach the searching, and then we'll be dividing the binary search into two halves based upon our middle element. So if my key element is less than middle, search will be left side. If my key element is greater than middle, search will be right side. Okay. In detail searching operations of linear and binary search, I'll make one more video. But my point is, calculating of complexity, it will take, as far as linear search is concerned, it takes big O of n. As far as binary search is concerned, it takes big O of log n, because half of the list, right? Right. Now, what is the complexity of hashing? So we are executing this function of hash function. So we will be knowing the location. So we need not to search a key by comparing each element. Instead, we will be going to the location and the comparison will be big O of 1, which is a constant. It takes a constant. It take big O of 1 only, because we will be executing the hash function. Based upon that, we will be knowing the location where the element will be available. So that is the best use of hashing. So hashing is what? Hashing is storing and retrieving the data with big O of 1 complexity. So these are the terminologies what we will be looking into and this is the small example to understand the normal hashing or general hashing. So next video we'll be going to discuss the types of hashing and collision resolution techniques that we'll discuss in the next video. Thank you all.